Barry. Barry, what do you have today?
Uh, I just wanted to, as a closeout on my vacuum chuck, this was the bowl that I had mounted with this, still had a foot on it for the show, and I didn't have the equipment there or the time to take it off. And so yesterday I went ahead and cut it off, and I was very pleased with. I have a short video that I made, but I don't want to take up your time, but it is about a 3-minute long video of removing that sharper tool would have helped me a lot, but you could take off quite a bit at one time and it didn't produce any instability. But again, I want to preach about if you make a vacuum chuck, try to make sure that it can get clamped so that the foam or whatever you're using for a gasket allows it to collapse down so it is hard mounted on whatever, whether it's PVC or wood chuck, so you get hard to hard contact. And I did some turning at about 400 RPM and about 1200. About 400, there was some chatter, but no wobble. And at 1200, everything went really well. And then I just put the Beal buffing system on it.
So in other words, the gasket makes the seal that holds the vacuum, and then the wood to wood or PVC to wood contact is what stops it from wobbling on the flexing on the gasket. So it's like a two-part bearing surface. Is that how I'm understanding it?
Yeah, a lot of in fact, most or all of the commercial vacuum chucks that I've seen, and I have never actually bought one. I've just looked at them online, but they all appear to have a gasket that completely covers the face, and they range from 1/8 inch to, I guess, 1/4 inch thick foam, and it just invites, no matter how stable it is as far as balance, if it all compresses nice and uniformly, there's still the issue of it is in effect a spring.
Yeah.
And so there's going to be one or more frequencies or RPMs at which your bowl or whatever you're finishing will set up a response. The foam is giving and yielding and shaking, and so it's going to produce chatter. It's not unsafe; it just can produce chatter, and so you have to find the single magic RPM where it doesn't do that. Whereas if you can suck it down right against the PVC chuck or right against the wood, there's no more. I guess everything is really a spring, but it's an extremely high stiffness value of a spring, if you will, when you clamp wood to wood or ideally wood to metal, but we're not making metal chucks here.
Okay. Anybody else with any comments or questions following on from Barry's presentation? I think quite a few of you were there.
Hey, Barry, I was always told to stay away from Venturi-type vacuums for vacuum chucks. But when I watched your shop vac demonstration, I was wondering how the ultimate vacuum of those systems stacked up to something like that. I just have no idea what you get. Do you have any knowledge of that?
Now, again, you have to understand all my knowledge is gained from endless watching and not from doing. But my endless watching, and that included commercial Venturis that run somewhere in the order of between $150 and $180. And the make-it-yourself Venturis, which bottom end, they're little more than a small hole drilled through with 2 big holes and a crossways hole, and that's your Venturi. And you can knock one out from a piece of aluminum 3/4 inch bar or something in no time. But the best of them that I've seen don't pull any more than a good shop vac. It's not a scavenger like a real vacuum pump. Each pass of the vane is removing some number of molecules from whatever's present. And as long as you can get a good seal, the scavenging action can remove virtually all the molecules you can never get an absolute vacuum. Even NASA, whom I used to work for, can't achieve a true vacuum, but they can get it down to where it's like 4 decimal places, 0.0001 vacuum to simulate space and other things. But a Venturi, I never tried it. And the reason I didn't make one or buy one was I have a little pancake type compressor. And I know it does not have enough CFM to drive the Venturi to effectiveness.
John,
A lot of you guys have big shop compressors.
Barry, I actually have a Venturi system myself, and it doesn't go up to the full vacuum you said, and it says that you must have at least 10 psi or 10 or 12 psi to make it safe. So I'm just, I understand what you're saying. I can't get up as high, but I've never, as long as I have the vacuum over the minimum that's recommended, even on the small ones, I've never had a problem with it, unless I've got a leak in the wood or something like that. And that's the biggest issue.
Right.
It just doesn't draw enough. So if you have any porosity anywhere in your vessel, it will fall off quite quickly. I suspect that if you have a higher vacuum like you're talking about with a vacuum pumps, that you might be able to get away with a little bit of porosity in your wood, or more porosity than you can with the Venturi one.
Well, if porosity even becomes an issue, I can say right away the Venturi is superior to a shop vac, because a shop vac is pretty much immune to porous wood. You could actually drill a small hole in your project, and if you enjoy the sound of whistling, it'll suck it down almost as well as no leakage at all, just because the system is built with so much inherent leakage around the adapter and the spindle and around the lid of the vacuum cleaner itself. You have all kinds of room for leakage.
The Venturi one that I have is one of the ones you buy from Woodcraft that goes off the pressure vessel, your large air pressure vessel. So it's like a high pressure vessel. And the biggest thing with those things is you have to have a big enough pressure vessel so that you don't lose the airflow. It requires a certain CFM of airflow in order to do it. So I think what you'd argue is that if you have to buy a big enough pressure vessel to run the Venturi suction system, you may as well just buy a vacuum pump.
Well,
Yeah, $75, and you're there.
Yeah, Barry's found very cheap vacuum pumps work well.
Yeah, exactly.
Barry,
I think
I have found over the years that a true vacuum pump pulls about an inch more of mercury in the long run in most situations, and does seem to have more volume that it can remove. Also, the O-ring material, if you used, when I first started trying these years ago, I used standard O-ring material, which is about 80 durometers, rubbers measured in durometers. And it was just not resilient enough. You could get a vacuum if you had a fresh off the lathe bowl that was very symmetrical. You could get a vacuum, but you could lose it just as fast. There's several people online selling O-ring material for vacuum use, and it's about 30 durometers. So it's much softer and more resilient than a standard O-ring.
Well, that gets you up.
I looked for that, Ernie, and I couldn't find it. The lowest I could find was about a 55 durometer. And I bought an O-ring, a 6-inch diameter O-ring. It's made for some kind of a water system. It's a 1/4-inch cross-section O-ring, and it was labeled as 55 durometer. And a vacuum, it was too hard to make a vacuum. You got leakage on it.
Barry,
The question is, which device makes the least sound? There's too many noises going on in the shop. So which way to create vacuum? Are the vacuum pumps very quiet compared to compressors or shop vacs?
Extremely.
Right there.
And also the
Yeah.
vacuum pump is not affected by length of hose. So you could actually have the little vacuum pump sitting over outside your shop or in your house proper and run a 50-foot hose. And the hose isn't going to collapse. You know, if you get these urethane compressor type hoses, it doesn't collapse and it doesn't have any degradation of effectiveness by running a long line. It's not like shop vacs where it relies on a fairly short hose or it just loses its usefulness.
Well, I also noticed that your vacuum pump was a lot quieter than your shop vac.
Yeah, I would say it's probably, I would guess it's probably around, maybe it's like a cheap dishwasher. It's probably about 50 decibels. Whereas a compressor can be up, you know, close to a 90 or something like that, 95, and shop vac is certainly up in that same range.
Okay. Any more comments on this whole issue, or do you want to wait for I think the videos that are finally going to come out on this from Barry and the club are going to be very illuminating. And
John, I've got a shot of these chucks I've made and a couple of comments too.
okay, I'm going to go to you next then, Michael.
Okay.
And I think Ray has something to say on this too, so we'll get around to all of you. Go ahead, Michael.
Okay, I'll do a share screen. So here PVC is really difficult to find. It's used for gas exhausting on high efficiency furnaces and water heaters and that. So ABS, and rather than using pipe, using unions, they tend to be more cylindrical than the pipe itself. So this is on the left is I think a 4-inch, maybe a 5-inch. As you can see, I put a calculation, 210 pounds of force at full vac. And the one on the right, I think, is about a 3-inch. And for my stripping, I'm just using foamed polyethylene. I think it's a packing material. I just cut it out and I put it on with ABS cement, or not ABS, but what do you call it? Contact cement.
Well, that'll compress down hard, that stuff, though, won't it?
Oh yeah, yeah, but I've never had a problem. I've never experienced any of the vibration that Barry talks about. I have one that's 5 inches. Actually, I sent him a note the other day. I made for the bowl lathe. I didn't have a tailstock, and I only had one faceplate, so I designed a vacuum chuck that fits in a regular stronghold chuck or a Talon chuck, and has a piece of copper pipe sticking out the back with a number 2 rubber stopper that goes into the headstock. One of the things, Barry, I think that you didn't touch on very much the other night is the adapter for the vacuum. And I didn't quite understand how you were, but I don't want to divert into that. I bought a one-way adapter 20 years ago. They are like $5 more than they were $20 years ago. It's the best buy on the market. They're about 125 bucks. I have a 50-year-old gas pump, a vacuum pump, like I used to sell when I started out with Fisher Scientific in laboratories. Thing is, still pulls 25 inches and has an input filter and an exit filter on it. It's a real old one that has a bit of a gas oil leak into it. Just has a piece of copper or cotton threaded material to pull in a little bit of oil, but they're foolproof. They go back, my God, they go back 50, 60 years, and they're foolproof. If you can find, I bought mine on eBay for 70 bucks. It was a government surplus years ago. But once you've had vacuum, man, it's the only way to go. If you do bowls, it's the only way to go.
Anybody else on this? Ray, you had something on this topic?
Yeah, I use vacuum a lot. One thing I found is I run into problems when I overthink it. Is, you know, you're looking at it, vacuum is different than putting pressure on because it seems it'll self-seal. So I don't, when you see the discs and everything with material on there, like the neoprene and all that, I don't use any of that. Contact makes shelving material, non-glue on the back, and it's very, very thin. You cut off a piece that you need, cut a little X in the center just to draw a vacuum. I put that over the piece and just put it on my disc. Anything gets on it, you throw it away. It works. Putting the seals and the stuff like that, the more you use them, then you end up developing a leak. When the piece comes off, it's gone. The other thing is 1 1/4 8 nuts are available through Granger or McMaster Carr, and they're about a little less than $5 each. They're a little bit pricey for a nut, but they are available. And the thing with the shop vacs, for years, guys have been trying to use the shop vac because they don't want to spend the money on a vacuum pump. And they just brought up the biggest thing that's been happening probably over the last 4 or 5 years. The gas pumps, that GAST, that come out of a laboratory are made to run. They run all day to create vacuum in a lab. That's why the guys like them, because you can turn them on and just run them. What happens with a shop vac, they're not made to run in a vacuum mode. I mean, vacuum, when you're sucking dirt off the floor, that same air cools that. When you put that in a vacuum mode and there's no air, you set the motor up for failure. So if you got a bowl that you think is worth $400 or $500 and you're trusting that $35 shop vac, take your chances. So some things you can't cut corners on. And when you go to that, the frugal guy does the frugal vacuum guy. You've probably seen him at the shows. He rebuilds those things. You can buy one for $100 and some, but he rebuilds them and you get it. They're like new. I know a number of people got them. It's a little investment, but you're dealing with a real vacuum pump. So that's it.
All right. Any other comments on vacuum chucking since we're all here on that?
I have one comment. Ernie, you're friends with Dave Houghton. I know Dave does a number of things with vacuum chucking, and he uses both the Venturi and also the conventional vacuum chuck. Wonder if you might invite him to join us someday. Yes,
we John and I have him on the schedule, and he's agreed to do it. But he actually works as an advisor to T something or other, TMI that sells all kinds of vacuum gizmos, and they have a Venturi really that'll run very nicely off a nail gun compressor. 4CFM will run it quite nicely. And they make a very nice line of vacuum chucks at pretty reasonable prices, about $75 to $80 for most of their chucks. They sell them in 3 sizes. But he, for years, used the refrigerator motor out of an old refrigerator. Now, there is at the time, Freon wasn't the bugaboo that it is now, but you can't just go cutting the lines in a refrigerator to steal the motor. You got to have the Freon taken out responsibly, et cetera, et cetera.
Harvey, yeah, okay, go for it, Harvey.
Yeah, I just want to mention I was able to pick up a gas pump by buying a compressor that was used by a renovation company for spraying VOCs and providing a face mask with a positive air pressure. And it turned out to be the same pump that you can then hook up as a vacuum pump. So if people are looking for something on the used market, don't just look for the word vacuum. They also can look for a small gas compressor. And I called Gas up or emailed Gas, and the guy says, yeah, it'll draw 26 inches of mercury. So for $90, it worked out really well. That's it.
Okay, anybody else on vacuum chucking, or we're going to go on to the next guy on queue here?
Wood shop. Thank God for wood.